Okay, so I'll talk about non-blocking database connectivity, or NDBC. And what is that? Well, that's my Twitter, that's my site, all my links are there. And I write about these things in my blog. It's quite brand new, it has like 2 posts. So if you want to join, it's the right moment. I mean, okay, so yeah, I work here at TransferWise, obviously, and we are hiring, like Helen said. So if you're interested, just talk to us. And a little bit about me. I joined the company more or less 4 to 5 months ago, and I keep talking about that I'm an open source developer, right? Because for me, it's about knowledge. Open source is about knowledge, acquiring knowledge, sharing knowledge. And this year, I finished the Oktoberfest for the second year in a row. So if you want a t-shirt, contribute to the community, it's great. And this is actually relevant because, well, let's just start from the beginning, right? I joined Quill a few years ago. Nowadays, I'm one of the maintainers. It's a Scala library that allows you to work out, let's say, a collection-like code, and that will become queries for you in compile time, right? So if you see that when it checks over there, it generates a query for you. Save, compile save, it's wonderful, it's beautiful, it's a Scala. I just remember that yesterday I was defending closure in the JVM Roundabout, JVM Wars, but still. So here's the thing about Quill. We have this wonderful library to do these things for you, right? It's about generating the SQL in a safe way. And obviously, later on, we execute that SQL. And to do so, we use many drivers that already exist. So we support all of those databases. Some of those databases are NoSQL, and we have some support libraries here. They don't matter that much in that case. Let's focus on the SQL libraries, right? The SQL databases. Well, like I said, we use drivers that already exist, that are already there, were established. And this is a common JDBC code, right? You just find a connection, you build a prepared statement, and then you get a result, you iterate over it, and everything else, right? That's basic. It's well established. It works. We'll just use that driver to run the SQL later on. There's just one important thing to say here, right? JDBC is blocking by definition, right? And why is that? Because if you look at the interface that defines a connection, we have statements, great statement, like you can see over there. We have prepared statements. We have the object per se every time that we execute something. So far, so good. It is what it is. That's how JDBC works, right? Fair enough. It doesn't, is that a problem? I wouldn't say it's a problem. It doesn't affect most of our applications if we are working with through the network, if you were making an HTTP request. It doesn't matter, right? We have to consider your environment, to think about what actually impacts the performance of your application. And in that case, not as much. However, some specific clients need more performance, or they need to make sure that their threads won't block when they're executing their SQL code. So we rely on Postgre async. That's actually, I think it started as Postgre async, but it actually has both drivers, a JDBC, an asynchronous driver from Postgres and one for MySQL. Wonderful, works very well. We used that for ages, and then that happened, right? It's a bit, okay, adding message with project not being maintained anymore. Yeah, then we started to get issues, people opening issues about, yeah, when I do that specific thing, it doesn't work anymore. There's not much we can do, but it affects directly our application, our library. We had to do something about it. And yeah, that's the issue I mentioned. Someone opened this one, drop support for Postgre async because, yeah, it's not being maintained anymore. So yeah, sure, let's do it. What are our options? What can we do? And at this point, I think I was talking to Flávio Brasil. It's an engineer for Twitter, the guy that originally created Quill. And then he said something like, oh yeah, we can solve this problem. Let's build a driver ourselves. Why not, right? And that was my reaction. But interesting enough, the ones that know me know that that's not true. That's not my reaction. That's my reaction. I'm more like that, right? I see a challenge, I'm like, yeah, like, it sounds like a great excuse to build a database driver, right? I mean, it's a perfect excuse. Suddenly, like, yeah, I'm in, let's do it. And then that's when the whole idea started. So the first thing was, okay, we will build a database driver, let's have a look at what we already have. So let's see how JDBC works. And in a very, very simplified way, that's what JDBC does, right? You have, as a developer, you build a connection. I'm skipping most of that, but you guys know that's the basic of the thing, right? You build a connection, you prepare a statement, set some parameters, execute a query. It's very simple, right? I mean, who couldn't build that? It's so simple. And then I started digging to figure out how to do it. And here is my first code example. This is very, that's just like the structured code, just to give an example of how you do that, right? Usually we don't think about it. When I'm using a database driver, what does it actually do? And at that point, I didn't know. I was like, yeah, I'm just using that. And then I was like, okay, let's do it. This is an example of how you talk to SQL Server. You can see for the port over there, 1433, it's the basic of SQL Server, right? And then you're gonna have here this wonderful bytes, this array of bytes. You use somehow some sort of input string, output string to talk to it, right? Really low level, sorry, JVM, okay. And then you write and you send some more bytes, and you read more bytes, and then you have arrays of bytes, and then you read entry pointers, pre-login packet, and if something fails, read record. Beautiful, isn't it? What does it do? Can anyone guess?
Reading stuff.
It reads from the right. It reads strings from the right.
Yeah. I was trying to reproduce what that previous diagram actually does, right? So this is the first example. And I was trying to reproduce that. All that code, all those beautiful bits and bytes that I had over there, they managed to get me here. Here we have 33 messages that we have to exchange with a database before your query actually gets to the database. The last line here, I don't know if everyone can see, it's a query drop table something, right? That code corresponds to the first 2 lines of the whole thing. Okay? By the way, what that code actually does is something like, hi SQL Server, and then SQL Server says, hi. And that's it. That's what that code does. Nothing else. It says the pre-login and everything, but the point is, it doesn't do much. It just checks if it's there. When you are in that level of talking to a database, it's proper low level. You have to send bits in a specific way to say, hey, are you there? Yes, I'm here. Can I please send you a query? Yeah, maybe. Yeah, that keeps going. Yeah, I'll get there. So yeah, 33 messages. So how do you learn about it? You read the manual, obviously. And I mean, you spend a lot of time reading the manual because you have a specific way to do so. And then you read a lot of code on GitHub. Those drivers, they are still there. Those principles, I mean, they talk to the database, right? So it kind of helps when you can dig into those drivers. The same way that I was digging into Mauricio's previous driver because the connections are there, the bits and bytes of the order and everything. But when it comes to like SQL Server, that we didn't have the asynchronous driver, I kind of started from scratch. So I have to read I still have it, right? The manuals, and I still go through the code from the driver. And there's one interesting thing though that I realized. This is a log that I put together, right? And you can see that you have like, at the beginning you have always sent, requested, and received. That's how it works. You send information, you request information, the database answers you back. And it feels quite reactive to me, right? Every time I send something, I get something back. Most of the time when I send something, some information, I get some information back. By the way, when you send something wrong, it's a pain because it doesn't answer back. So you don't know if it's wrong because it doesn't answer. And you don't know why it's not wrong because it doesn't say, no. It's not like, hey, can I send you a query? And that's it. It's not like, no, it's wrong. No, you cannot send me a query. You have to send me something. No, if one of those characters is wrong, you don't get anything back. It's kind of painful. And yeah, I spent my time writing these things. Okay, so now I'm reading the manual, I'm reading code. How do I define an asynchronous driver, right? Well, we have to rely on some specific frameworks. The first one is Netty. Netty, everyone that works with Java is using Netty most likely behind the scenes. Netty, it powers like many of the servers we have, like Akka, Twitter, many things in Twitter, many things that demand high throughput, like a strong performance when you are moving a lot of data through the servers, through the network. So that's why it's a synchronous network application framework. And besides, we have futures, Treneo futures. That's an interesting one. We have Java futures, right? That's not the best. And then we have completable features, what's slightly better. Twitter has, and then we have it like Scala features. That's better than those ones as well. And Twitter implemented their own features because there are some flaws in the previous ones. Flavio, the same guy that started Quill, he wrote his own features. He works for Twitter, so he knows what are the flaws. There's some interesting benchmark here you can check that's actually faster than all the others. It's very interesting. So we decided to build it on top of those two. And yeah, what we're thinking, okay, we commonly have the connection. That example is simplified, but in the real world, you don't instantiate the connection by yourself, right? You use something else, use a data source. And commonly you have a third-party data source. And it's, what's the famous one? C3PO, something like that, right? I don't remember. Yeah, that's one, isn't it? Yeah. So we consider that as well. Why should we use an external thing? Let's implement the data source as well. So we have the data source, we have the connection, we have an exchange. An exchange is a concept, it's the guy that actually is transforming the messages, right? Because the idea was, let's make it readable. Because when you're reading the manual of those databases, you have clear concepts. I'm sending a query message, I'm sending a execute action message, I'm sending there's one that's the handshake message. So you abstract that, and then we have this guy that transforms the messages into the details, the bytes that will actually go to the database. And then he's the one that talks to Netty, and Netty does that in a high-scale kind of way. Oh yeah, and the thing is, because we're thinking about having that in a proper asynchronous way, you cannot block that. And because you cannot block that, you have to have features all the way since the beginning. Who here works with asynchronous programming on your everyday life? Who here works with web development? So all of you work with asynchronous development as well, by definition, right? All of us work with that, even though we are not manipulating that even though you cannot see you're manipulating that, it's already there. So the idea was, okay, every time that I do that, I'm gonna have like this whole the whole sequence of futures, and then somehow I'll have my result at some point, right? So for the ones that are not very technical, I'm sorry, now you see a lot of code, okay? Okay, so here is my first example. I have the connection. This is real code. That's real code from NDBC. And that's the definition of our connection. As you can see, everything here is a feature, right? We return features of absolutely everything, including void. Did you know that void's a type in Java? It's weird, isn't it? Yeah. Doesn't sound that obvious, actually, but yeah, it's there. So we have the import. Also, mostly when working with a database, we have prepared statements. We have instead of ResultSet, we just have a list of rows, because at the end of the day, that's what it actually is, right? So we have the prepared statement as well. And as you can see, the prepared statement works with futures as well. We have futures, and then we have the wrapped connections that is provided by the data. Oops, I'm looking at the wrong one. This was, sorry, the prepared statement here. That doesn't matter that much. It does exactly what the other one does. It wraps the values you want to send to the database, right? And you have a row. A row returns, wraps the result of your database. Something that was important here is we wanted to make sure that it's strongly typed. What was quite difficult because we are talking about Java and the type system is kind of weak. But yeah, that one not that interesting as well. And then we have the data source. The data source is the guy that you'll be using if you are using NDBC by yourself. So you can see the methods you have here, they are pretty much the same as you have the connection, but it wraps the connection and takes care of that for you. You don't have to think about pools of connections and this sort of things. We handle that as well. So we have data source, we have Postgres data source, we have implementations of data source. The whole thing is very well modularized because the idea is, okay, it has to be simple to implement the other database drivers, and every time you decide to use one of them, you don't have to take like everything, right? It should be light. It should be light, you shouldn't have anything that you don't need. There's a moment when you have to start the whole thing, right? Because thinking about futures, there's a moment when you have to eventually unwrap that. You have to say, okay, I want that result at that point. And that's where you should do that at the end of the world, right? Or at the edge of your application. Sometimes you don't even see when it happens. If you're working with Spring, for instance, the ones that were there know what I'm talking about. Spring unwraps that for you at the end of the day, but you don't see it. But you can just execute that and say, okay, I want that result in 1 second. 1 second is way too much. In that amount of time. Otherwise, that will give you a timeout exception. So I have the pool data source. You don't have to worry about that one as well. It's already wrapped as implementation of the previous data source. It gets complicated in the data source supplier. Because to build a lib that's entirely asynchronous, you cannot block absolutely anything. If some of the libraries you have over there, sometimes they wrap the result with a future, but at the end of the day, that's not asynchronous because behind the future is still being blocked. You need something that's intrinsically asynchronous to produce your result, and you cannot block at any moment in time. That's why this code doesn't look like Java code at the end of the day, right? I mean, some of my peers complain that I write code that doesn't look like Java, but like, it's my thing, right? Like, I work with Clojure, and let's push it a bit more. Let's make it a bit more functional. It's doable. It's painful. It's doable. So we have those guys here. We have many objects that are related to marshals and unmarshals are the guys that they try to interpret the results and the messages you're saying to the database. We have many abstractions. When you are reading the code from the previous drivers, it is very procedural, and it's difficult to make sense out of it. The idea here was, okay, let's abstract the messages. Let's make it a lot more composable. So even this is the data source supplier, meaning that even the data source, you don't use the data source at that very moment, use something that you generate a data source for you. So the whole process works in the sense of you have a data source that will provide you with the future of a connection, that when you try to execute something, provide you with the future of a result set, a row, list of rows, that will provide you with the future of something else. So it's entirely declarative. That's the idea with something that's entirely asynchronous. And here we have the NetE4 thing. This is the specific thing of NetE4. I think that's what caught my attention. You don't write that on your everyday job, right? You don't have to go so into the details. And like, it fascinates me that when I can go so deep down in something that commonly we don't do. It's way harder, but like, yeah, I enjoy it a lot. So here we are generating the threads, and see, that's beautiful. It's art, isn't it? I mean, it's not Clojure, it's not Scala, but it's beautiful. And then we have to create, like I mentioned, we have to create a connection, we have the create connection supplier that supplies something, that creates something, that creates something. But the thing is, you just declare that. When you start executing that at the end of the world, we have a future, and then you decide what you do with that. This is one of the examples I have. So that's how you use it. So you have a data source here, and then you say query that, and the get timeout is the one that defines how long your code has to actually execute that to bring you a result. Otherwise, timeout. Like futures work, right? Any news? Anything new here? Yeah. So, okay, we have the data source test, doesn't matter anymore. More code, yay. So, I talked about those guys. We have, as you can see here, we have many of the concepts that we use on the everyday development to some extent. Functions, you have bifunctions, you have suppliers, you have schedulers, and all that beautiful things that you have when you are working with the Java concurrent package. The next one would be a channel. And this one is an interesting one. That's the one that defines how you talk to the server, saying that, okay, you can send a marshaller in this, you send a message with the one that interprets the message, you receive back a message with someone that will interpret the message as well, right? It is done via net channel, where Java can be difficult, right? Well, where you have your context, and as you can see here, this is the guy that requests something, that built that message, request tells the server, please send me back something. This is a hi, send me hi back. And here we have the other ones as well. Receive, when something, oh, this is the timeout one. When receive is still pending. We have other messages, channels closed. This one doesn't matter much. It's way into the detail of the thing. Okay, we have the channels, we have the marshals, I talked about that as well. We have here some of the messages I mentioned, the way that they are encoded and decoded, with like sync, startup, SSL, and it keeps going. We have the exchange, that's one of the marshals. So yeah, read the manual, it will make sense if you read the manual, but then again, maybe. But the idea is, this is a message that represents a query in Postgres. If you have a look at the MySQL implementation, it's entirely different. We have the exchange here, the guy that actually worked out those queries, those messages, the one that you send a message, get it back, and keep the machine running. Because it's always a long sequence, like the other one I showed you. You send a query, you actually exchange 33 messages, actually more. We have the exchangers, simple query exchange. I think it's enough code. You suffered enough already, right? So, okay. You have a database driver, right? Now what? No one writes code with a database driver by yourself, right? Nowadays, you always use that with a framework or something like that. Remember at the beginning of the talk, we started the whole thing because of Quill. So recently, what happened was that I finally managed to integrate with NDBC with Quill. So now it's actually one of the drivers behind that tool. What generated like a nice tweet from what would be the leader, the technical leader of Quill nowadays, a guy, Alexiov, that works for NASDAQ, I think. And he was a speaker in Scala Days or Scala B or one of these Scala interesting names recently. He's a guy that has like a great knowledge about it, and it's really cool to work with him. By the way, when you join the open source community, you always eventually will like have the opportunity to work with like these great people. You learn a lot. I strongly recommend that. So in summary, it's written in Java because of adoption. The main idea was, okay, the previous one was Scala, right? But now that you are writing that, what about we build that in Java, that will be easy for Kotlin to adopt that, or Clojure, or Scala. So that's, personally speaking, I think that something that should be that well spread around to make it easy to be adopted should be written in Java, because it's really, really low level, and you don't suffer with annotations. Netty for asynchronous communication, well established. Most of the powerful tools we have that deals with I/O is powered by Netty, great tool, and Traneo futures for high performance. The future. So plans for the future. Data streaming, I didn't talk about that, but we actually can stream some of the data. It's like a work in progress. We're using that reactive project reactor. That's it, right? We have like our implementation. What's funny, remember I mentioned the type system in Java is weak? You cannot transform anything to anything, so it's painful. You have to implement your maps and flat maps yourself. I mean, it's hard work, but, well, it's for the greater good, I think. I intend to write the SQL Server driver. I intend to write a closure wrapper. As promised, I promised someone that I would mention closure here. It's powered by NetE4, but possibly we would have Akka powering that one as well. It would be interesting because Akka is quite powerful. And if you have Akka already in your stack, maybe it's easier to adopt a tool that uses Akka. And this one is interesting, isn't it? Thinking about adoption again. If you want to make something well known, you kind of have to have, I don't know, a deal with the devil sometimes. And then the challenge here is the fact that Spring is based on JDBC, like most of, absolutely everything that talks to the database, meaning that's not reusable. I cannot just implement that. I have to rewrite absolutely everything that uses JDBC, what makes it quite hard. But hey, I'm up for a challenge, right? With the dev.
Hi, just one question. The train.io, do they have an IO implementation as well, or just future?
Which one, sorry?
Do the library, do they train? Do they only provide future, or they have IO as well?
Just features, promises.
There's no IO. Okay,
No IO.
That's my question.
That's why we're using NetE.
Hi there. Congratulations on having your pull request merged in GitHub. This is always, a pleasant thing to happen in anyone's life.
It's my project as well.
Yeah, certainly. Now, I'm not necessarily coming from the Java backend development, right? So I was just wondering, like, when it went down to picking the actual reactive programming primitives, you went for the futures, aka promises. Why not reactive X or something more complicated then?
So that's why we started before it became a big trend. Let's just start simple, right? I need those basics first before I have something streaming data. So the reactive one is kind of a work in progress, but it's like a lot more complex to implement that yourself. So it's a work in progress, and because they started like a while ago, and we work on that one in our free time, right? So we defined first how we could replace the basics of database drivers. Streaming would be the